characterization of an unknown Rhinolophus bat species based on morphometric analysis. So to start with, as we all know, Philippines is located in Southeast Asia and considered as second largest archipelago in the world. So there are more than 20,000 species, and the great portion of this are bats. Bats are considered as the sole representative of order Characterizing. So with 78 currently identified species, it is considered as the most diverse order of mammals in the Philippines. So bats are good ecological indicators of habitat quality, and also they are good bioindicators of both disturbances and contaminants. So generally, their appearance varies greatly. Family Rhinolophidae. These are the horseshoe bats. Only one genus, the Rhinolophus. Rhinolophus is second most species genus of bats. Worldwide, over 80 species are currently recognized. Fossils evidence suggests that the family Rhinolophidae is closely related to family Quibod. So, their distinct characteristic, elaborate folds of skin around the nostrils used to focus the ultrasonic squeaks used for the echolocation. In the Philippines, there are 10 species described, wherein 4 species are endemic to the country, namely the Rhinolophus virgo, Rhinolophus rufus, Rhinolophus subrufus, and Rhinolophus philippinensis. Evidence has shown that this family is comprised of species groups, and according to Heaney, family Rhinolophidae is poorly known group in need of much further study. These are the 10 Rhinolophus identified or recognized in the Philippines. The Rhinolophus acuminatus, Rhinolophus arcuatus, Rhinolophus burnensis, Rhinolophus criabi, Rhinolophus inops, Rhinolophus macrotis, Rhinolophus virgo, Rhinolophus philippinensis, Rhinolophus rufus, and Rhinolophus subrufus. So, for the statement of the problem, Heaney posted interesting questions about the rhinolophids of the Philippines. What geographic circumstances have promoted speciation? How much ecological separation must exist to allow species to live together? And how long do these processes take? And how genetically different do the lineages become? So these questions can be answered by studying or identifying species, like what I'm doing, what my thesis is all about. And then a detailed study of their morphology, genetics, and ecology will show that at least twice that current number are actually present. So, the University of Philippines Los Baños Museum of Natural History had a cave expedition in Samal Island in 2012. So, were species of Rhinolophus captured and cannot be placed to any identified species in the Philippines. So, that captured Rhinolophus species is the one that I'll be using for my study. So, the big question is that the Rhinolophus that was captured is a possible new species. So, similar menstrual characteristic with the Rhinolophus virgo, but differ from Rhinolophus virgo with the nose leaf, connecting process, cella, and the ear characteristics. This is the main statement of the problem. In an attempt to substantiate the hypothesis that a known species of Rhinolophus obtained from Samal is indeed a new species, and analysis of external and craniodental characteristics will be further explored. So the ability of the molecular studies in conforming species is no doubt to be essentially effective. However, it is expensive. So right now we're looking for some funding in order for me to conduct this molecular study. Thus, potential external and craniodental characterization will be considered as an initial step, as initial basis in determining the identity of a potentially new bat species. This research primarily aims to characterize the unknown Rhinolophus bat species based on morphometric analysis, the external and the craniodental measurements, and to assess if the unknown species captured in Sample Islands is indeed a new Rhinolophus species. So for the methodology, this diagram shows that we cannot identify a certain species based only on morphological characteristics. Meaning, we cannot say that morphological characteristics is the only gold standard for you to identify. But you have to know the DNA or the you have to have the DNA or the molecular analysis, the geography, ecology, morphology, and the reproduction. So my focus is, our initial step, initial basis is the morphological characteristic or the morphology. So I'll be using a digital caliper. So the process or flow chart of activities, data mining. I'm going to gather all possible journal articles and then get a lot of data for me to compare those data to my data. And then voucher specimens from previous studies on Rhinolophus in different museums, Philippine National Museum, Museum of Natural History, and University of the Philippines. Then the external morphological of the Rhinolophus species from the Sample Island. Then sculling of the known Rhinolophus bat species, the cranial and dental morphology of the Rhinolophus species from Sample Island. So a total of 50 characters will be taken from each specimen. So these are the characters to be measured. The picture shows the right wing and body of Rhinolophus, then the skull of Rhinolophus virgo, then lateral view of the skull, ventral view, the dorsal view of the skull. So this was the data, what has been done so far. So for the Rhinolophus acuminatus, number sampled is only 2. One for the external and one for the craniodental. The Rhinolophus arcuatus 3, one is juvenile. Then the external and craniodental, one for the external, 2 for the craniodental. Rhinolophus burnensis, no data, and as well as the Rhinolophus criagi and Rhinolophus subrufus. And for the Rhinolophus inox, 4 specimens, 2 for the external and 2 for the craniodental. The Rhinolophus macrotis as well as the Rhinolophus philippinensis, number sampled only 1, and both for external morphology. Rhinolophus subrufus and Rhinolophus virgo, 2 numbered sampled, and both for external, 1 for external and 1 for craniodental. So for the scanning, cut the skin on the mouth part of the specimen. And then carefully strip off the skin, cranial and the jaw. Then cut the atlas. Then detach the skull. So clean excessive muscles by carefully stripping pieces off using a fine tip forceps, then put in a box with a soil within a fine mesh, or you can use stockings covering. Put in a place where detritivores and decomposers are attached. Then after 2 weeks, you have to check it. Then soak in a 5% ammonia solution to remove the excess parts. Clean in a flowing water, then carefully brush, or using forceps, and then air dry. So dermistids larvae are arthropods, belongs to order Coleoptera, or flesh-eating beetles are preferred to use. But if not available, ants belongs to genus Caribara will suffice. Soil can attract detritivores or decomposers along with the process. So, photos taken during my data collection.
Process of sculling. If you want to see, take a closer look, pwede siguro natin. So she will be using a smaller bath, which is a Haplodictylis fisheri kasi mas maliit yun. So, which is halos kasing laki niya yung Rhinolophus so that we can tawag niyan, yun yung size talaga na itatanggalin niya.
So after i-tanggalin yung skull mismo, lalagyan dapat ito ng cotton sa loob. Order. Yung skin yung pagpal.
So, nandiyan na, nakita niyo yung skull and yung skin. So, basically, after you're going to remove the atlas, diretso siya sa soil. Kasi, magiging natural yung decomposition ng brains and all of the internal organs na eyes, yung nasa loob ng skull, para hindi siya masira. Kasi, once, pag ikaw mismo yung nagtanggal, you can actually do it para malinis siya. Pero, there would be some parts na hindi natin alam, like mga jaw joint na matanggal siya doon. So, better would be if you're going to do it naturally. So, dermastids are the one that we can get dermastids in every museum. Kasi ano sila, actually, best siya in a museum kasi kinakain niya yung mga specimen. Larvae yung ginagamit. And then, according to our source, which is Dr. Larry Haney, 2 to 3 days ay pwede na siyang kunin, but we haven't tried it yet. 2 to 3 days yung dermastids, sobrang bilis niya, then ano na lang siya, hugasan mo na lang siya. So, in the absence of dermastids, ants na lang siya. That's why you need a fine mesh na stockings kasi kailangan mo siyang takpan na hindi dalhin ng langgam kung ano man yung parts ng ng skull na meron ka. Kasi ang langgam has the tendency to bring everything in their home. So, kaya dapat kaya niyang pumasok, kaya niyang lumabas, pero hindi niya kayang dalhin kung ano man yung part ng skull na nandun. So far, actually the skull that we have distributed, practice lang siya kasi we've just tried kung if it will work. And I think okay naman siya, malinis ba yung skull? And then also the important thing is with the specimen mismo, so kailangan maging intact yung niya pa rin, yung characteristic ng bats mo, na once you remove the skull, you can still see all of the other parts, like especially the nose leaf and the ear characteristic, which is the distinguishing characteristic in some species, like especially Rhinolophus, and you have other Hippocyderids, Vespertilionids. So that's why you need to carefully cut it na wala kang ibang makakat. So para ka lang comparative anatomy, na nagtatanggal ka ng mga maliliit na tissues and then remove it carefully. Okay? Do you have any question?